We're lucky to have Ken Beezley. He's a full-time instructor up at Davis and Elkins College, full-time. That's a lot of commuting because he lives in Pocahontas County. His love of trees began in 2000, so 25 years ago, when he started a portable sawmilling business with a friend. Hooked on trees, Ken went to Glenville State College, where he earned an associate's in forest technology and began work in the industry. In 2006, Ken saw an unmet need in the tree care market, one that focuses not on just affordability, but on the science behind the trees that dictate proper care. The tree services, now Tree Sources, began there. He became a certified arborist and began working with residential, commercial, and government customers to provide the highest quality care. In 2012, he returned to WVU, received both a BS and an MS in Forest Resource Management. As Ken and his family moved to the wilds of Pocahontas County, Ken applied those forest management skills to his business and incorporated another business, Little Levels Lumber Company. But like I said, he's also a full-time professor at D&E, so his emphasis is really going towards that. And he teaches in silviculture, timber harvesting, forest and wood products, forest ecosystem protection. So he's well versed in what he'll be talking about. So without further ado, here we have.
Well, thanks for having me. It's nice to be on the last tree talk. I think you had Mark Double last time. Yeah, really a great guy. I conversed with him a little bit when I was up in Masters at WVU, and some of his colleagues I still talk with and talk about plant pathology and things, killing trees. And I got Kristen Wickert here. I wish I met that one. Did Kristen come?
No.
Kristen did come. She was on the list.
Yeah,
So maybe next time. Yeah.
Yeah.
But like mentioned, yeah, I'm at D&E teaching forestry in our new program. I think this is the third year. Former roommate or office mate for Iris. So now I have a big office I don't know what to do with except kill plants in the window. But mainly I teach courses in sustainable resource management and forest technology. Hopefully, when we get more time when we're faculty, we can have some courses in arboriculture and tree care to kind of broaden the breadth of what our students are learning outside, more forestry and tree emphasis. But this lecture, stress strain in trees, and we'll talk some about tree risk assessment, which you guys are blessed to have a certified arborist, at least in Elkins. Some places I've used to work, there's no tree ordinance in town of what you can and can't do with a tree and how the city regulates trees. So I'm always interested. Does Elkins have a tree ordinance?
Yes, we do.
Good.
Yeah.
That helps a lot. Tree City, USA.
Yes, right.
That's good. So you definitely receive some elevated care as opposed to places that don't have that benefit, because some municipalities don't want to sacrifice that budget item, right? Mm-hmm. So good for those folks that incorporated that. That'll work. We got to turn it on. There we go.
I'd like to say something about that, what you just said about the budget item. We found out.
I can be the clicker.
We found out that we didn't really have to add a budget. We already were spending as much money on collecting the leaves,
Oh.
and they let us count that. So that's how we became a tree city. It wasn't a change in the city becoming any more generous towards trees, but they hated the leaves. So, enough.
Well, good. Yeah. Always helps to be a little proactive. There it goes. All right, so a quick overview. We're talking a little bit about tree mechanics. I'm mainly focused on subterranean parts of trees in my graduate work, because I think everybody gets a lot of emphasis on the canopy, the above ground parts. So we'll look a little bit about tree biomechanics and tree and root soil relations, and what we do with tree assessments and try to incorporate those into tree assessments. And a little bit about basic tree assessment. There we go. So benefits of trees. Most of you are tree board members, or hopefully you realize the benefits of trees, from shade, reductions in utility costs from shading effects in the winter and summer of different trees, wildlife value. Of course, the one I always like is aesthetics. Like I'd say your federal building at the post office downtown. Has blue ambient lights. Had some time, I snowed in a couple nights actually, got to walk around Elkins some. And it was kind of subtle, nobody out, and you see this blue haze with these trees. I don't remember, some type of cherry. I didn't like the species too much. Sometimes I throw on my plant blinders when doing tree assessments after a point sometimes. Just, well, it's a tree, let's enjoy it.
Yeah, it's a tree.
Many benefits of trees. Of course, this are the city park, it's just a little extra flair to the background there to have a nice mural in it with some trees and shrubs and things in the background. Of course, I always look at, this thing has got some old pruning scars. But that's how it is, right? Sometimes done in the past, all we can do is keep going towards the future and do proper practices as we go on, but they seem healthy. Then we'll talk about targets and, is that tree a risk or not? Every tree is subject to failure. Oops. Of course, we get wood products from trees. Most of my classes, we touch a little bit on history, time of European contact. The King England was coming over, they were putting the broad arrow marks on trees in the upper New England states. They reserved these trees for ship masts, for their ship-of-the-mast battleships. I don't have a picture. Naval stores were real big in South Carolina and Georgia. We extracted tar to make pitch, which all went into waterproofing ships and waterproofing hemp rope. So we've been using trees and wood products for quite a while. Dutch architects would send scouts out in the southern U.S. for live oaks. They wanted certain parts off of different live oak trees. And so people would take plaster casts of these trees, send them back to France or England or the Netherlands, and an architect would say, I want this piece. So they would extract certain pieces from the trees. And of course, this one I stopped a while back as a sophomore in high school. I was going down the road one day, coming back from work, and they had done some road clearance of trees. And there's a 16-year-old splitting locust post right beside the road with his dad. I was like, you do not see that much anymore. So utilization, so just other values and products of trees. And of course at school I use them for teaching instruments. This is an environmental science class. This is a 52-inch diameter red oak tree that fell last fall. If you've been up to the property urban forest lately, it's right across the trail. So hopefully we'll get some tree cookies off of that, do a little dendrochronological studies, date the tree a little bit, see what was going on with it. Maybe get some wood products out, so maybe we can solve some things out and sell them for a benefit or something. But even there, just having that tree there as big as it is just on the ground, because standing up, yeah, it looks big, but on the ground, this is a massive tree. And of course, most of the time we think of trees, in park-like settings. This is up in Nova Scotia, where I was up for a conference a while ago. Of course, if you've been to Watoga yet, to their old growth forest, they've got a stand of eastern hardwoods, about 250 acres roughly right now, with trees scattered through it that missed the initial logging when it ceased 100 years ago. So there's some nice specimens in there. But when we're talking about street trees, this is more typical of what we're looking at. I don't know if these are Quazon cherries or what type of cherries are downtown. It's a nice little tree, kind of fits its spot. Nice little niche in there, hanging out, nice showy flowers. I'm sure some of you all have worked on these trees for years and know every one of them. So there's different types of care we put into trees. If we're on a tree board, if you think we stick this tree in the ground, then what? Besides even watering, and people breaking limbs off of it. How's the form and structure? We'll get into a little bit later. It's like if we need doing structure pruning, trees are like little kids, they're better to train while they're little. Right? So if we do some things while they're younger, it'll have long-lasting effects as the tree ages, especially for branch attachment. A lot of times these branches get crowded and prone to breakage. Then you get a break and a scar, and then maybe some insects come in, or it's just a vector, an entry point for certain diseases. Of course, this is what we want to try to, avoid, is catastrophic failure of trees. And this is from the derecho of 2012. These were trees that hit some estates down in Charleston when I was working down there. And we'll talk a little bit, of course, wind is a big disturbance. My next slide. But, right here's a paved road. Look at that root ball. So they've had impact over the years. We've encroached on the root system of the tree. This one is right against the pavement. So we've kind of done some things during development that now we know we should try to avoid or preserve trees during construction, especially mature trees. Another picture sliced right through a house. And these, you get a call from somebody. Most of the work I did during the derecho was just clients. I couldn't take on any new clients. It was just all people that already worked for companies or firms. Yeah, the insurance company, they don't even come at these most of the time. After a big storm, they're like, get the tree out of there, get everything, the tree cleaned up, and then they'll come do their appraisal or assessment. Fortunately, nobody was home on either of these that got hurt. So trees are prone to, predisposing factors. Without humans, they're susceptible to biotic or living agents, insects, disease, pathogens. The deer, you guys probably have urban deer everywhere. Do you see any white seedlings anywhere? No, deer come along. Yeah, they love them. They love them. If you have the right conditions for those acorns to sprout, they're not going to last too long unless you have a fenced-in enclosure, and then hopefully something else doesn't get them. That's my. I don't care for them in the woods. I like deer jerky for a reason. Of course, they're exposed to rodents, insects, and then abiotic. Those are the non-living factors in our environment, such as wind, temperature, light. But the single most destructive, failures occur because of wind for trees. So because of wind, combined with anthropogenic or man-made causes, wind does a lot of damage. And some of these can come from, I don't have pictures of other ones, we had tree limbs that failed because of improper pruning, or trees that were topped out. When you top out a tree, you get that vigorous sprouting. If you take off one limb, depending on the age and the vigor of the tree, you can have 100 there where you make that cut. And those grow up for about 10 years to reach the previous canopy height, and you have all these stems competing, and all these, the branch attachment. If you think of this flat surface and there's a stem trying to grow from around that cambium layer, and it's real tight, you have weak branch attachment, they break off in storms. Sometimes they're massive, sometimes they're as big as a pencil. But wind is the single most destructive factor for trees, at least in eastern United States and Appalachia. And of course, humans, humans are another one. We like to have a house in a woodlot. More construction with more people move into suburbia and wanted woodlots. They want to encroach on trees. So sometimes, even though this is in a residential setting, you can see this tree is going to be affected somehow, depending how much roots were severed. Sometimes it's not so much root disturbance, it's soil compaction. That first pass of a piece of equipment, whether you're on a construction site or in your yard, if the conditions are right, that first pass of a vehicle is going to compact the soil. And if it's a dry spell, that's going to harden off and basically get like a fragipan, where water nutrients can't penetrate through that. And it's going to run off to the sides. And that's one of your first steps of starting tree decline sometimes, especially if it's a mature tree. Mature trees, they're a little more sensitive to root disturbance. And a lot of time, because of root disturbance, I get a call because the tree's already a goner for some reason. The people haven't been keeping an eye on their tree. The best thing you guys can do is, just look at your trees every year, every season, every day if you can, and notice what's going on with them. A lot of times arborists get calls just because, they neglected their tree for a while. Didn't look at it. So humans, this is a tree topic for our tree morticians there. And then other things, I don't know if you guys know this fella. You ever see him running around? Doug Wood, right? So some people are eastern woodland tribes used to use bark scribing on trees. So basically our native peoples could scribe on trees, and even though tribes and nations didn't speak the same language from Maine to Georgia, they could scribe on trees and communicate with each other. But mainly this was for, this guy and maybe the warriors that were with him, and they would say, this little thing's pointing to water or fish over here, but basically there's 4 people sleeping there. There's one person there and he's got 3 captives. So they would talk, but this is pretty injurious into the tree. So as much as we want to go back to indigenous ways, we can't be doing that on our yard tree very often. Or we're going to kill it. Other impacts, of course, not so much pruning, management is planting sometimes. And I go around, take some pictures. This is a newly planted tree around, and it's just sitting right in this water bath.
I know where that is.
Yeah. I don't want to incriminate myself. So sometimes planting site, mostly disturbed soils, try to plug a tree in the ground. I'm not a good planter. Some people can plant anything. If I try to properly plant this tree, it'd be dead in a year. It doesn't matter if it's the most fertile soil sometimes. I don't have a green thumb like that. But at least I can look at this, that we've got a clay soil and it's rocky, all this is overburdened. We put a tree there and it's saturated with water. So, will it survive? It depends. We'll see. I'm monitoring it. I'll tell you next time. Of course, sometimes roots are opportunistic. We put them in places where we want trees. What's our root growth like? Is it restricted here? Usually if you see roots that are coming to the soil for lack of nutrients, for water and air basically. The soil's too compacted down here, the roots are going to be easier to grow at the top of the soil than try to go under the sidewalk somewhere. And that depends on species. I think, you probably know, there's a visor on a building here. I can't remember what type of tree that one is. Is it? It is a maple. That's right. It's just leafing out right now.
Yeah.
And then this one, volcano mulching. This is another tree. It's down there. The mulching height is just too high. And a lot of times the trees are planted too low, and then they mulch too high. And then basically we get moisture inside of the bark. It attracts slugs. It disrupts the cambium system and just leads to a slow decline of the tree or stunts the growth. Oh, back to that guy. So we look at plant functions, and I'd say if most of you are on the tree board, you know a little bit about photosynthesis. Trees need to photosynthesize. That's how they make their sugar, their foods. So they have to photosynthesize. They reproduce. Hydraulics is water conductance. I always say the 3 primary functions of a tree are live, reproduce, die. In about that order. So they all want to, once they germinate, sprout up, they want to be the tallest tree around most of the time. They're waiting for an opening, or they're taking advantage of an opening to photosynthesize and get their crown way up there. Of course, they want to reproduce because they know they're going to die at some point. They're going to reproduce because at some point they need their progeny to carry on, or maybe it's a slow climatic migration that they want more seeds to be carried further because they're stressed out. But we're looking at the mechanics part of tree biomechanics. Oops, which I don't have that on here, do I? My notes. But we're going to look at tree biomechanics, which basically incorporates plant form and function is what we look at, and we kind of compare it to construction attributes for buildings, timbers, long spans. So tree biomechanics combines construction and engineering principles with plant form and function. Trees respond to stress in a couple of different ways. This is the last thing a tree wants to do. Unless they're a tip and mound species like a red spruce or some other species, they don't want to uproot because they're pretty much done. They would rather break here on the stem or shed upper parts of the limbs of the canopy than risk root failure. So trees fail 2 ways. One is by root failure, the other is by stem failure. Even though the stem broke off, there's still the possibility it could send out some epicormic sprouts and persist. A break that low can be detrimental, but you can see you got a little planting strip there. There's a big tree. Look at that little root wad. Not much of a root ball there. So tree biomechanics, here we go, applies engineering concepts to plant form and function. So it studies the behavior, the mechanical behavior of trees. But generally, I always like dealing with triangles for whatever class I'm in. Mechanics basically looks at wind loading, the form of the tree, and the material properties of the tree. So every species of trees has different material properties, and that's water content. They have fiber strength qualities. Some can resist breaking more than others. Some have flex. They bend more than others, and that depends on the time of the year. So we have yield points. We kind of know by species. You know, we have little regions here, like a limb where a root can flex before it reaches a point of deformation and it doesn't pop back. Because then once the tree reaches a yield point and a failure point, this plastic region here, the tree has to respond. So it has hormone signaling that goes on. And we call this basically its reaction wood. So trees hold themselves up, and let's see what slide I got next. A couple different ways. But we'll talk about this a little bit more in a minute. But species have different points of failure. And some, it depends if it's an improperly pruned tree and we have little shoots going straight up in the air instead of, you know, a nice spreading architecture, they're more prone to breakage. And if they're more brittle, like a silver maple, they're going to break a lot sooner than other species. So what we try to do in tree biomechanics and with our building construction, we're basically mimicking nature. I mean, the Greek architecture used buttressing to support loads because they saw trees doing the same thing. You know, so we have columns supporting loads with a little bit of flare, trunk taper at the base, and there's a bald cypress tree. It's my buddy Rob down in Georgia. And also we try to mimic trees in buildings. If you've seen any of the earthquakes that's been happening in Asia, the buildings are swaying back and forth. I don't know if you've seen that. It's pretty impressive how much those buildings can use. They use a form of mass damping, which basically, these have balls in the center of them, so the ball sways back and forth. The shaking of the building is transferred to this ball and it dissipates the energy. Trees work the same way in harmonic balancing and mass damping. So it basically, if we have a wind event, the tree tapers off the tiny points, and that's where most of our energy is going to flow out to those points and dissipate. Same thing happens, energy goes down the stem of the tree and into the root system. So trees use different mechanisms to avoid tree failure. This tree does not want to fall over or break right here. It would rather shed some of these limbs because there's too much energy going through it than that transferring to the root system. So back to our elastic limits. Inside the tree at the cellular level, there's different hormones that are signaled in times of stress, basically. And when a tree is stressed and it has to use hormones, that means it's using reserves from something else. So if a tree is stressed too much and building reaction wood, it's putting reserves somewhere instead of making leaves or growing roots. It's trying to make a defense or react to something. So it's a little more prone to a disturbance than it would naturally. So that's when we get back into pruning and construction and taking care of trees during constructions and drought stress. Well, that's one I just threw in there. So we measure this with stress and strain. So stress is a unit of force, the strain is the displacement, basically. I don't know if we need to go into this that much. But this is critical in tree biomechanical research because usually we'll want to apply some type of stress, which we'll get into in a minute, and measure the resulting strain and see how much the Germans pulled trees over. And, you know, they did it in certain soils and put winching system on, just pulled the whole tree over. And so, well, how much force does it take to pull a tree over? And then we can kind of extrapolate from that, you know, how much wind can these trees handle with a certain root ball. So we applied some of this tree biomechanics to tree form and function. There's a windmill, it's kind of acting like a skinny little tree. You know, they bend in the wind. So certain wood properties can flex and bend at certain rates depending on the tree species. So we have a tree bending here. Anytime a tree bends, the windward side of this is held in tension, this is held in compression, which I got that on there. There we go. And that's important because for hardwood trees, their reaction wood is formed in tension. And for softwood trees, pines, spruces, firs, their reaction wood's formed in compression. Has anybody tried to cut down a leaning pine tree? I think they're the most hazardous because all all the reaction wood is right here. And if the tree is leaning this way and you go, you're supposed to put your notch in, safe felling requirements, you bore in and cut through the back. You cut through this too much, the whole tree's just gonna pop in half and fall over. That happen, it's not fun. The hardwood tree, the exact same lean with tension and compression, you can make all the wedge here you want sometime. This isn't gonna move till you come cut in the back and relieve the tension. So it's important for tree safety for arborists to know where tension and compression is, where reaction wood is. One of my buddies did, this is part of tree biomechanical research, they were pulling limbs, and basically they inferred there's certain cutting when we're pruning trees. Why are we pruning trees? So sometimes it's because this little branch angle right here, it's too tight. So we want to reduce it or cut it back because it's more likely to fail if this has a greater than a 30% angle here. It's more likely to survive pulling or a static load than a tree that's real tight. So it goes back to we have pruning requirements that arborists use. And some of it is this branch angle attachment and how far to cut back and where to cut. So this is kind of important. I did tree pulling, static tree pulling, where we pulled trees just a little bit, measured how much force it took to pull it, and then the energy that went from the tree down into the root system. But we did it on a college campus, so we couldn't pull the trees over like the Germans. But we're in Morgantown. If we'd have done it over homecoming weekend, I got a PhD.
Or if they beat Pitt.
What's that?
Or if they beat Pitt.
Yeah, there you go. Yeah. But this is just real quickly, so we use digital image correlation, which we make a white, what we want to measure, we put a white background on and then speckle it with black paint, and basically all these little dots, we measure how much they move from the original to when we pull them. And there's a thermal image basically that we get of strain in certain places. It was boring. And all we did was just validation of the previous literature. We all kind of knew, it was theorized that the wind blows this way, there's more tensile strain on the windward side than the leeward side, and we knew that. And that was one of the biggest things that came out of this paper. And then torsional stress is yet to be researched. So root systems. If we're talking about root systems, some of you guys probably know, what's a root system supposed to look like. It's hard to underground until they uproot and fall over, but most of the time a tree uproots and falls over, you just got to shelve the root system because all the fine roots basically are broken off. A lot of people think that the root mirrors the treetop. On very small trees it can. Some people think that we have these long descending roots. In some places, not around here, we don't know. But basically, all our roots, this goes down, this is about 3 feet right here. And this is on a mature tree, and as you go out towards the canopy of the tree, the root system is closer to the top of the ground. If you look at the root ball, the big red oak tree up in the urban forest, go look at it, how big a tree that is, and basically how shallow the root wall is on it. It's probably not 2 feet thick from the ground to the end of the root. Not very big, and that's mainly because the deeper we go, the less soil and water that's available. So trees are opportunistic, they're going to grow out. They're going to go where it's easy. Some trees like walnuts and hickories and beeches, they'll send the taproot out. Most trees will. They get pretty deep, but as soon as these lateral roots are established, that taproot basically dissolves because the tree doesn't need it. It's all these roots out here. Well, all these roots basically hold in tension. If you think of this as a mast on a ship and it's got ropes to the ground, all those ropes are basically in tension holding the tree, pulling it one way or the other. If we're all around a tree holding a rope, it goes that way, we're going to pull it back, it's in tension. We got to keep the rope tight so the roots all around the tree system are in tension. This one, this guy in France had a really good paper, which you can see these roots, the tree's leaning, these are held in tension. These are compressed a little bit, but basically all the roots are held in tension, and it's a soil root plate complex that anchors that tree to the ground. So most big trees, when you see, they've got a whole conglomeration of rocks and clay and everything. They've kind of got a big pot they're sitting in, but all these fine absorbing roots that collect all the nutrients and anchorage are closer to the soil. growth, some roots, most tree roots, there's a transition zone. They're a little different than stems. Like the cambial layer sometime in roots is in the center of the stem, and as it goes up the tree, it transfers and the cambial layer is on the outside underneath the bark. So there's a transition area in here. This is a transition zone within the root. So basically the root fibers are shorter, so they're more active and anticipating vertical loads. And this is just the pith and the steel, another transition zone. So what they're doing is they're transitioning from below ground and prepared to go vertical. So why is that important? Well, we've got this tree here. I always like looking at all these planters. That's a nice one. It's got Elkins on it. And this is one we kind of looked at earlier. It's like, boy, what are the roots doing there? You know, what's the life expectancy on this tree? I don't know. Some of these trees are going to outlive us, and this one that looks okay might be gone tomorrow. So, of course, we do things like this. I guess a little pot there. You know, a big tree and a little pot, where's all that root system? It's right in there. It might be going down in there a little bit. And we do construction practices right at the edge of big oak trees and sever roots that offer some of that stability. Not only do they lose some of that stability, they lose the nutrient uptake potential, mainly water. And we see a lot of this. This is pretty common. A lot of trees that you see in urban areas after storms, they come out something like this. And of course, tree preservation during construction, I'm not going to say where this is, but it was left at the edge of a construction site. It still has the sediment barrier over the root wall. So this was just a row of pine trees that had nice neighbors with full crowns on the outside. They removed all those, and you get all these trees basically with no limbs or canopy till the very top, and they get real limber because they lost all their buddies to protect them from the wind. So that's why that one was a goner. The wind got it. Of course, there's a stem and upper canopy. I'm not going to go too much on that because so parking lots, once something's going on, I think these are pin oak trees planted in about a 4-foot strip up in Morgantown. And pin oaks seem to thrive fairly decent. Some species would not tolerate a small root zone, but we do have some dieback up there starting. And so I took these pictures of all these pin oaks. So they're probably not getting the nutrient and the water requirements that they need because it's got a little tiny growing strip. This one was just a couple weeks ago. I walked outside my office and I've been looking at this dead ash tree. It's just hanging right there outside the doors on the right. And I was like, I need to tell maintenance about that. I walked out to my truck, I came back, I saw these 2 students standing there, and this was laying right there. And it was a dead ash tree about that big around, and I was like, did you guys hear that fall? And so the 2 minutes that I walked to my truck, and they weren't there, they came outside right when that tree fell, within a couple minutes.
Wow.
Yeah, they're standing there. I got permission to use their picture. But that was a dead tree, so that goes back to some of our risk assessment that we'll look at. It's like, how do we prioritize things? Like, well, dead trees, targets, where people are going to congregate, they get a little more attention than a tree in the woods. So we get into tree risk assessment. How do we evaluate trees? There is methodology to it, basically to try to remove bias. So that you don't want one arborist or one tree company coming to your house and saying, that tree's going to fall over, you need to cut it down, which is probably fairly common. Used to be a lot. People knocking on doors saying your tree's unhealthy, you should do something about it. And a lot of that's scare tactics, right? Hopefully it doesn't happen as much as it used to, but with the tree ordinance, it kind of helps prevent that a little bit. So we do 3 assessment components. A tree with the potential to fail, an environment that may contribute to that failure, and then a target is a person or object that could be injured or damaged because of that. And I got a little worksheet we'll go through here in a minute, but all trees have the potential to fail, depending on different attributes, depending on the environment. Derecho comes through, we could have the health history around, and during that last derecho, there's huge monster oak trees I'd worked on in the Kanawha Valley that looked like somebody just took a giant weed eater to the top of them and shredded them. It was incredible, not to mention the trees that were laid over. And I'm not a storm chaser either. I have friends that, they can't wait for a storm to come through so they can load their gear up. I don't like that. So we have risk, and risk is the combination of the likelihood of the tree to fail and the severity and the consequences. And I got a little diagram here so you don't memorize all that. And hazard is the likely source of harm that is identified as the tree or parts of the tree which will affect the target. But this comes back to as risk. Sometimes as a tree owner, as a tree board, you have a responsibility to manage your trees. I'm not sure how your ordinance is set up, but the city of Elkins in some places, it's probably the tree owner. And then you guys are the stewards of certain trees. So you do have some type of responsibility, but with that, you guys would assume more risk, especially on larger trees because you like trees, right? More than likely, you're going to say, I'm not worried about it having a big tree right out my back door, unless there's something wrong with it, but I'll keep an eye on it. If it needs something, I'll do something about it. But other people might, you might sell your house, somebody else moves in and it's like, I don't like these trees, and cut them all down. So there's different levels of risk acceptance. So what the tree risk assessment does is try to remove some of the bias. So we have these, we'll go over these just a little bit. So we have a likelihood of failure and impact. So a likelihood of failure, which we'll go through in a minute, is it's imminent, you got a dead tree, it's probably possible, it's imminent or probable that thing is going to fall down. Even with the slightest bit of the wind, and we look at the likelihood of it hitting something, a picnic table, a car, do people hang out under this tree all the time? It's the only tree around if it storms, or people going to go to that tree. Is it over a building? Is it a parking lot? And then we take this metric and we put it over here, this likelihood of failure with the consequences of failure, which severe is death. If it's in a schoolyard and it's a dead tree, we should probably remove it, right? So there's three types of risk assessment. As a tree board, I'm sure you guys do a lot. This limited visual survey, a window cruise, you're walking around just looking at trees, looking at the buds and the flowers and the bark, maybe some of the wraps that are on, just looking at them, noting things. A friend of mine is an arborist for Arlington County, Virginia. He manages 20,000 street trees. So he's got an iPad device, and they've got a GIS inventory with GPS data of all the trees that they manage, and then maintenance schedules, problems. People call in about a tree falls over. For you guys, it's probably, not quite that big, but you guys have tabs on every tree you've planted probably, right? One way or another,
Yeah,
you know what's going on.
We do visual, we're all maniacal about it. We walk down and we check on things,
Right.
even in our various neighborhoods, and then people are starting to realize that we have the services of an arborist, and if they have any questions, we take photographs and send it to our arborist,
Oh, good.
and then he's down here about 3 times a year as well. So, yeah, these are our babies, so we do
Right.
have a tendency to look over them.
So we got our limitedness is, basic is kind of an advanced limited survey, but maybe, I carry a little knife or something with me, not on your all's trees. If I see other trees on campus have issues, I have my little glass looking at things. That may be climbing, level 3 is definitely getting and doing a climbing assessment. I haven't done those since we left Morgantown. Those are fun. All I get to do is climb around a tree all day and document the tree. Those are pretty fun. So we're looking at factors that affect the likelihood and consequences of tree failure. Of course, the International Society of Arboriculture, maybe your arborist has something similar to this. A lot of firms have their own. This is a basic tree risk assessment form that we'll look here in a bit. This is free. This is an older one, but it still gives you everything you need to look at trees, to document a specific tree. But look right here, there's that table again. that same table, when we're doing a risk matrix of what should we do to this tree, you know. So back to here, I think, you know, categorizing the likelihood of failure. If it's imminent, it's gonna, you know, something bad is gonna happen really soon. That tree is gonna fail, it's gonna fall over, you got a branch or a tree support cable that's fallen and you see the bark cracking, you know, and, you know, it's a red flagger. Probable, you know, under normal weather conditions, it's probable that tree's gonna fail, or part of the tree. It's possible that the tree could fail during normal weather. High wind failure is elevated if it's possible. Improbable, you know, hopefully that's where we want all of our trees in our tree inventory. Is there a probable of failing? But the likelihood is still there. And then this other little metric, the likelihood of impacting a target. The chance of impacting a target is remote. You know, that's a tree, you know, in a park that's not very well traveled. Maybe it's in a place that's unkept. It could be a tree off in the distance that doesn't have anything underneath it. There's no targets underneath it. It's low if the target will likely be impacted. You know, if there's a swing set nearby and the tree would fall over, it's low. Medium, and then high, of course. You know, this is where there's things, you got a dead tree in a playground. That's a high one. So that's another one on here. But we can look at this tree here. From a distance, we know, so it's got some bark sloughing off of it. Got an old callus wound there. It's an oak tree, but we get close. Look at this vertical cracking. You know, and this isn't even without, you know, not looking at the canopy at the top. I can't tell if those are dead right there. We got some structural issues right there. That one, you know, the likelihood of failure is pretty soon. And the likelihood of impacting a target is pretty medium. It looks like this is kind of in an urban setting. So this would be one that we would throw up on our list to call your arborist and say, can you come look at this? So it's likely, from this table, this tree, the likelihood of failure and impacting a target, it's likely. So just remember likely. Let me go to this other table. The second one is the consequences of this tree falling and hitting a target. It's this low property damage or personal injury is unlikely. It's not, you know, it's in a low populated area. It's kind of out by itself. Maybe it's on the edge of a wood line somewhere. But we go all the way up to severe, you know, high value property damage. One or more people could be killed or injured. So that's this table here. So then we go back to our table again, but look, it's at a playground. It's this tree here, and say it's over this playground, similar to City Park, but luckily you don't have any trees like that. So we go back to our little likely from the first table, and we say, well, it's likelihood of failure, but the consequences of failure are severe, and we say, boy, on our table here, it goes to high on our consequences of failure. So that elevates it to an arborist to say, this needs some attention. So what next? You get a tree like this, or any tree that is coming up to somewhere that is higher than any risk you want to assume. Well, we have to go back to our little assessment form. And some of these are pretty complex, some of them aren't. But basically, when you get a form like this, the arborist usually doesn't tell you that you need to remove that tree. You know, as an arborist, I would say, based on all these and these calculations, you know, the probability of this tree failing is pretty high. Do you accept that risk or not? Or it's low. Can you mitigate the risk somehow without removing the tree? So we can prune trees. You know, if the tree's not dead, if it's got dying parts in it, we can do structural pruning. We can do things to kind of extend the life of the tree or to mitigate it. If it's got a big limb, it's going to fall down. Smaller street trees, structural pruning. They'd be really low on your list. You know, if those little trees fall over, you know, maybe it hits somebody in the head a little bit or falls on a car, it's probably not going to kill somebody, but structural pruning is one that's pretty low, that's usually overlooked by a lot of tree boards. You stick a tree in the ground, you forget about it, you water it, it looks healthy, and 15 years later you're having issues because you've got mottled branches, or your branch attachment is too close, your branch angles are too tight. If you just do a little bit of pruning every once in a while, they can help prolong the life of that tree. course, bigger trees, you can install cables for support, different type of canopy support, especially if you've got a couple limbs that come down a multi-stem tree and you're worried about it failing. You can remove the target, you can move the playground. I used to get calls that people have large trees out the back of their house, and well, would you worry about it, Ken? And I'm like, no, not really. I'm like, well, what if it's your granddaughter sleeping there? I was like, if you're gonna lay in bed and worry about it, is it worth the stress? You got a couple instances. You can mitigate it by maybe pruning, maybe removing the tree, or you move. So it depends how much risk you want to accept, and everybody's risk level is different. Of course, tree removal. I put this in there as I should have put it. Topping is not recommended, especially on mature trees. Hopefully everybody knows that. But in certain instances, it can be acceptable. If you have a large tree that is dangerous and the immediate threat to people is to remove that target or top it out, cut it, and then maybe you come back at a later date, soon after, and then remove the entire tree. So topping, it's not recommended, but there are certain times where it is kind of acceptable if you're trying to mitigate potential injury or death. Moderate crown reduction by selective pruning is preferred when height reduction is indicated. So we can pull the top back on certain tree species just a little bit at a time and over time to try to reduce the crown sometimes. Most people, that's why topping was so common and kind of still is well, come give my tree a haircut. It's like, it's not going to respond like a privet hedge. Well, I say privet because I got a lot of them in my place. Hardwood trees especially, they've got two different types of wood. There's mature wood and immature wood, or juvenile wood. So basically on hardwood trees, anything about 3 years or younger is juvenile. So the potential to make a cut on a juvenile piece of wood and that callus over and compartmentalize increases as opposed to mature wood, which takes longer to seal off the ends of cuts. So that's why, in France, like espalier and pollarding is popular. If you've ever seen pollarding, it's a tree that looks like basically a lollipop. But every year or two, they're cutting off all that juvenile wood that's callousing over, and they're basically like a coppice system. They just keep cutting off the new growth, and it keeps flushing new growth. And people kind of brought that to, well, if they do it in France, we can top our trees here, but they're topping trees over 50 years old. So, how do we do some tree risk assessments? We talked about our visual and our basic and advanced. Some of the more advanced ones, our structural method are looking at decay detection. This is basically like ultrasound. You can put devices around the tree, look inside the tree, and look for cavities, different types of wood. It goes off of moisture, and the wood fiber material gives you a nice little graph, really expensive. Anybody else has one? This is another one. This is ground penetrating radar. They can map the root systems out on trees. Pretty expensive too. I don't know anybody around that has one. Resistograph is kind of common. It is invasive. It's got like a 1/32 inch drill bit, and you can drill into the tree, and it's got a little graph. Now they got a USB that puts in it. So while you're drilling through, where you have resistance or less resistance, it measures where rot is. And you look at that graph and say, well, okay, this has internal decay. Even though it has internal decay, it doesn't mean it's doomed. Oh, that's a slide to put in here. Anyway, I got sounding hammers. I was sounding on a tree earlier. Soil probes. This right here is probably the most overlooked thing in an arborist toolbox sometimes. Soil probe. If we're going to plant a tree or something's going on, take a soil core, pull it out. Has the site been changed? Maybe they resodded their lawn for some reason. I did a lot of work in Spelter, West Virginia. Everybody's been over there. They used to have a big smelter there, and they created some type of batteries. There's a lot of cadmium and lead and zinc around. Zinc. So as part of the remediation efforts, the town, everybody could apply, and they could get lawn remediation to remove these heavy metals from their lawns. So the bioremediation company that was hired to do it did it, And they were working there a couple of years, and I get a call, I was like, Ken, man, look, these trees, some of these trees are dying, why? Why are they dying? I'm like, what are you doing? Had to go visit the site, and it wasn't all the trees, but basically, it wasn't so much that they were removing the topsoil and putting new sod down. You know, usually they're using excavators or skid loaders or stuff, and they were mechanically damaging the roots. You know, so there's a lot of root damage, and then, you know, the topsoil they put back was severely compacted underneath the sod, so it restricted nutrient flow and started killing the trees. So that got pretty messy. We do static pull testing, so those are structural methods, things we can look at. Static pull testing is not common at all. In Germany, yeah, maybe because they like pulling over live healthy trees. This is really not too applicable. This is just backing up some of our strength data and load data.
So can I ask you a quick question about that? So in Germany, when they were pulling over these live trees, what's the point? I mean, they find out it's a good tree, but it's now dead because they pulled it down.
Yeah, basically they were testing for wind loads. They thought that, so these tests are static loading events. So it's a constant force, which doesn't really technically mimic the wind, right? Because a tree is doing different things, and it's hard for us to do dynamic testing on trees because we got to sit there and wait for the wind to blow and have all this equipment set up. Probably not going to happen. So the static load, they can infer that certain loads can be catastrophic to certain trees and certain soils under certain conditions.
Okay. So that becomes like a guinea pig for the others then.
But
That becomes like a guinea pig for all the ones like
kinda, yeah. At least there was something baseline that we could go off of. And, I mean, our trees, we're pulling over. I mean, large pin oak trees to 1 degree of natural lean, which we had a little level here. And last thermometer that measured how much the tree was tilting. And 1 degree lean down here, it's like, that's not very much. The whole top of this tree was, even on a big tree. So they could say in some of these windstorms, these trees are up to 6% lean sometimes before they reach a point and bounce it back. So 6% just, you know, flopping all over the place. And we were doing 1%. I'm like, oh man, is this legal? But, so we have our 3 basic surveys, but you know, just a window survey, you have to be out and walk around sometime. You guys probably know where this one is? It's in City Park.
Oh, City Park.
Yeah, just like maybe there's some mulch there and it got washed away. So I just saw a little picture of that, and that's about an annual canker, a nectarium canker that hits walnut. But you can see we'd have structural issues later on if we let that tree get very big, just because we have a weakness around that wound. So I always like to say, right tree, right place, right function. Anytime, that's the hardest question I get is like, what type of tree would you plant? For me, that's a hard question. Because I think most arborists sometimes, they've got a little cheat sheet and they just go, yeah, I can get a deal on these Quantifying cherries, or I can get a deal on this and this, you know, but really God knows, you know, what soil are we putting this tree in? Probably the most important factor, whether how much sunlight it's going to get or watering, is what's the soil, because, you know, what's the soil under this guy? You know, probably get a lot of salt runoff from the road, cigarette butts and ash and beer and, you know, just everything. And this poor little tree right here, he's kicking away, he's doing all right. And it's hard to, you know, we can't amend these soils, put certain amendments in them if we need to. But most of the time in urban areas, all this soil here, it's built up urban soil. It's not native soil to start with, right? It's probably just a clay and rock mixture, a bunch of junk that they just filled holes with. Say, hey, we got you a tree planting pot. But some trees survive. That's why we plant some of these species, because they're really hardy. Your Kentucky coffee tree out here, those are pretty hardy. I like those. My wife. Whoops. What time is it? Yeah. But when I was first working in forestry, we had to live near Parkersburg, West Virginia. We bought a house that had monster Kentucky coffee trees around it, so I grew to love them. But they make smaller varieties. I can't remember if it's the cappuccino or the latte now that are good for street and urban plantings. They're really hardy to harsh soils. Pretty cool tree, I think. So right tree, the right place, and the right function. You know, why are we planting trees? Of course, you know, it's got showy flowers. You know, it's better than just having a concrete landscape, right? If we put a little shrub there, it's not going to last too long. The dogs are going to pee on it. Something's going to chew it up. We got something that's a little hardier that can withstand a lot of weather. But then we gotta think, you know, what's our future maintenance for pruning, watering? We gotta think about replacement. Structural pruning is a big one to look at sometimes. Next. Yeah, all right, I got a couple more minutes. Public service announcement, if you don't know, I always like to do one kind of pest, but oak wilt disease. It's been studied in the northern United States since about 1940. It's really rampant in the Midwest and down in Texas. I'm surprised that like West Virginia, some of our states don't have this out on, you know, the public information websites to say, watch out for oak wilt. If you don't see it too often, but when you do, if I get calls, the tree has oak wilt, it's done. You can't do anything for it. There's no fungicides you can inject into it. There's no treatment for it. Basically, you're just waiting for the tree to die. If you get a big dead red oak tree over your house, it's more expensive to remove a dead one than it is alive. But first time, watch out for premature leaf drop, about July or August. They'll kind of turn yellow. Some won't be all the way yellow and like, oh, that tree's just turning early. If it's a red oak or a scarred oak or a black oak or even a white oak, you know, I'd be really looking into it. The leaves will turn. I mean, I've seen monster trees in the forest, healthy one year, the next year dead as a doornail. And I've got calls last year going to look at some red oak trees in a campground, you know, and they had somebody come in doing some work, and that's not why I was called. It's just one of their trees wasn't too healthy, and I'm looking, and it's like, huh, all right, where's an arborist been? And then about 3 doors down, I see a large red oak with a limb off of it. And then there's a stump beside it on the other side. What happened down there? I was like, well, they had some tree work done. They cut those trees down. Like, well, this oak fungus persists in sawdust. So if you work on an affected tree and go to another one, especially a red oak tree, you can carry the fungus with you and then start the climb like that. It's really picky. It's a fungus, so it likes wet springs. And if it stays dry, hopefully it's not too persistent. But it's pretty detrimental. It has these fungal mats underneath the bark. It will get pressure pads underneath the bark. You'll see little black vertical cracks. Typically in red oak trees, it'll attack all oak trees, but mainly red oaks. You see a little crack and you start pushing on it, or take a sounding hammer and it sounds hollow. It's like these pressure pads get in there. It's the fungus getting in the cambium system and start to strangle the tree basically. So yeah, oaks within 1 year of infection, some takes 2 to 6. Of course, you know, it's primarily by root graft is the most efficient means of transportation. So from one red oak tree to the other's by humans. It's spread by oak beetles, which are pretty ineffective. But they say if there's a cut in the wood, some research, you know, if something happens, this is forced scenario, that a tree is injured, it can be infected in less than 30 minutes if this guy's around. Or it can be root grafting, you know, it's hard to control. Down in Texas, this is what they do. They sever all the roots around oak wilt in a whole patch to try to contain the spread, but it's not too feasible in West Virginia. I think it'll roll down the hill, it's too rocky, right? So sometimes we just have to let it go. Sometimes it'll kind of burn itself out if it can't graft onto other red oak trees. There are preventative measures. You can get basal injections of certain fungicides if your tree doesn't have oak wilt to prevent it from getting oak wilt. But I think it's just something to watch. So nobody wants to lose a big red oak tree in their yard. So I guess I just set my clock. Ran through a bunch of stuff. This little guy. You see that little tree there? It's gone now. Somebody must have clipped it off. I've watched it all winter. It's growing out of this old meter pole. There's a little hole where they put a flag or something used to. It was growing. It was another cherry tree growing right out of there. And I walked by today, and unless I was looking at the wrong one, it's gone. I was wanting to keep an eye on it. Just where it's opportunistic. And, that's Pendleton County. They had stumps and trees for their gravestones.
Significant.